This video is on coordinate geometry, plane shapes. We're going to be doing two examples of quadrilaterals where we classify the figure in the most precise way possible using slopes and distances. We will also find the perimeter of each of these figures. So these are going to be quadrilaterals instead of triangles. That means there are four sides. So our chart down here has four spots for our sides, our four slopes, and our four distances. So we're going to start with our picture here. We have a quadrilateral, looks like WXYZ, and you can name it. You can start with any letter and go in a circular manner. You can go clockwise or counterclockwise. So I went WXYZ, and that's how I named it. So I'll actually start down here. I'll start with segment WX. Then I'll go X to Y, so segment XY. Then segment YZ, and then back from Z to W, so segment ZW. Now the reason why I'm making sure that I do go into the correct order is because these automatically give us our opposite sides. I'm going to make a little note here. Segment WX and segment YZ are opposite sides. So these are opposite of each other. Let me fix that. But then also segment XY and segment ZW are also opposite sides, which are helpful for when we're classifying. So these are opposite sides. We are going to be finding the slopes of each of these side lanes, which is our change in Y over our change in X. And since we have a graph, we can count our change in Y and then our change in X. So from W to X, I'm going to have my change in Y is 1, 2. So that our change in Y is positive 2. Divided by our change in X was going to the right, so 1, 2, 3. It is a positive 3. So our slope of segment WX is 2/3. The next one is from X to Y. So from X to Y, I will go down. So that's going to be a change in Y of negative 1, 2, 3, 4, 5, 6, 7. Negative 7. Divided by, so this was the location I was at. I'm going to recount that. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go to the right. So that change in X is going to be positive 1, 2, 3, 4. So it'll be a positive 4. So our slope of X segment XY is negative 7/4. Now another reason why we want to have our segments written like this is because since these are the opposite sides, segment WX and segment YZ are opposite of each other, that means that segment WX and segment XY are connecting sides or adjacent sides. So I'm going to make a little note about this. These two sides are your connecting sides. And they share the same letter, so that's how you know that they connect. Just like segment XY and segment YZ share the letter Y, so they connect at letter Y. But the reason we want to know connecting sides is because some of the properties utilize connecting sides are congruent or connecting sides are not the same. So we want to know if connecting sides are also part of this. Next up we have segment YZ. So our slope is change in Y is going to go down, so that's a negative 1, 2. Divided by our change in X coming from here was going left, so that's going to be a negative 1, 2, 3. So a negative 2 divided by a negative 3 is a positive 2 over a positive 3. Last one is segment ZW. So from Z to W, I'm going to go up. So our change in Y is positive 1, 2, 3, 4, 5, 6, 7. Put a little dot here so I know where I stopped. That's a positive 7. Divided by, so from this dot, I'm going to go to the left. So that's a negative change in X. 1, 2, 3, 4. Negative 4. So our slope, positive 7 divided by negative 4, is a negative 7 over 4. Now that we have all our slopes, let's look at our opposite sides and then our connecting sides. Our opposite sides, so WX and YZ, have the same slope. That means that those two lines are parallel. XY and ZW have the same slope. Therefore, they are parallel. We have opposite sides, so our two sets of opposite sides are parallel. Opposite sides are parallel. The reason why we want to look at this is if we have a list of our possible quadrilaterals, we can eliminate ones based off of this one piece of information. A trapezoid only allows one set of parallel lines, so this is definitely not a trapezoid or a right trapezoid or an isosceles trapezoid. A kite has no parallel sides, so this is not a kite. So this can either be a parallelogram, a rectangle, a rhombus, or a square. Those are the only 4 options. Then the rest of it comes from the distance. But we also want to look at a rectangle and a square have to have right angles. So we still want to look at our slopes. Do we have any perpendicular? Those come from our connecting sides. So 2 over 3 and negative 7 over 4 are opposites, but they are not reciprocals. Therefore, these are not perpendicular. Since they are not perpendicular, we do not have right angles. That eliminates rectangle and square. So the only 2 options we have left are parallelogram and rhombus. But we also have a quadrilateral. So we just need to know if it's a rectangle. Wait, it's not a rectangle, if it's a parallelogram or a rhombus. So looking at our distances, we're going to be using the Pythagorean theorem again. From W to X, it is, I'm just counting, 1, 2, and then 1, 2, 3. So we have 2 squared plus 3 squared is equal to C squared. And remember, we're going to solve for C, so we're going to end up taking the square root. So the square root of 2 squared is 4, 3 squared is 9, so 4 and 9 is 13. So we have the square root of 13 units. Next, we have from X to Y. So again, we're just going to count. We have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So we have 4 and 7. You can also utilize the coordinates of seeing that this is going down, so that change in Y was negative 7, and then change in X was positive 4. So we can actually utilize our change in Y and change in X just like we did with the without a graph. So we can utilize the change in Y of negative 7 in parentheses squared plus our change in X of positive 4 squared equals C squared. We will be taking the square root because we're getting C by itself. Negative 7 squared is 49. 4 squared is 16. So 49 and 16 is a positive 65. So it's the square root of 65 units. Then from Y to Z, I can count it, or I can use my change in Y and change in X. From Y to Z is 1, 2, 1, 2, 3. So 2 and 3. And I do have a negative 2 and a negative 3, but again, we can utilize that without the signs at all because it's just counting, or we can use the parentheses. Change in Y is negative 2, then we square it, plus parentheses, our change in X is negative 3, and then we square it is equal to C squared. We'll solve for C, so we'll take the square root. Negative 2 squared is positive 4. Negative 3 squared is positive 9, so 4 and 9 is 13. So square root of 13 units. And our last one from Z to W, I can count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So I'll use a 7 and a 4, which over here I do have my change in Y is 7. Plus my change in X was negative 4, so I'll put that in parentheses, negative 4 parentheses squared. And again, I don't have to use any signs because distances will always be positive. And this will equal to c squared. Solve for c by taking the square root. 7 squared is 49. Negative 4 squared is positive 16. 49 and 16 is 65. So we have the square root of 65 units. So now we have all the distances. Let's compare. We look at the opposite sides first. So wx and yz. Wx is square root of 13, yz is square root of 13. Well, if those are opposite sides, are congruent. We also look at the other set because we want to have two sets of opposite sides. Square root of 65, square root of 65. That is two sets of opposite sides congruent. All sides are not the same, so that eliminates a rhombus. The only thing left is a parallelogram. Parallelogram says that two sets of opposite sides are parallel and two sets of opposite sides are congruent. That means that the classification is a parallelogram. And again, if you're looking at the list of all the possibilities, you can eliminate possibilities as you go because of the types of slopes we have. So we look for parallel and perpendicular, and then we look at the distances. So we will know based off of certain information what we can cross out, and whatever we're left with would be our answer. The last piece of this is to find the perimeter, which again is to add up all the side lengths. So we have the square root of 13 plus the square root of 65 plus the square root of 13 plus the square root of 65. And again, you do not put decimal values until the very end, because if you do decimals and then add the decimals and then round them again, your perimeter can get slightly off because of all the rounding of your values. So we'll round this to the nearest tenth. If you add them all up, you get roughly 23.3 units. Again, anything with distance should have the unit of measure associated with it, and in this case it's just units since we don't have centimeters or inches, so it's just units. So again, we're looking at the slopes of opposite sides and also connecting sides. So opposite sides are parallel because they have the same slope, and then connecting sides are not perpendicular, so that eliminates right angles. So no rectangle, no square, no right trapezoid. Then we have two sets of opposite sides are congruent, not connecting, so it's not a kite, it's two opposite sides. So that would give us the parallelogram. Next, we're going to do question 4 without a graph. This is going to be quadrilateral HIJK with these 4 vertices. So without a graph, we want to go ahead and list out our names of our sides. So we're going to go in order from H to I. So we'll have segment HI. Then we'll do I to J. So segment IJ. Then we'll do segment J to K. And then we'll go from K back to H. So we'll have segment KH. Without a graph, we don't have anything to count, so we do need to list out our change in y's and our change in x's so that we can do our slopes and also so we can do our distances. So I'll write out our 4 segments, HI, then IJ, then over here I'll have JK, and then we'll have KH. So our HI, for HI, our change in y is from -3 to 0, which is adding 3. And our change in x is from 1 to 2, so that is adding 1. Next, we have from I to j, our change in y goes from 0 to 2, which is adding 2. Our change in x is from 2 to -4, which is a subtraction of 6. Next, we have from j to k, our change in y from j of 2 to -1 is a subtraction of 3, and our change in x from -4 to -5 is a subtraction of 1. And then our last one, from k back to h, goes from our change in y from -1 back to -3, which is a subtraction of 2. Our change in x goes from -5 to a +1, which is an addition of 6. Now that we have this information, we can utilize this to help us find our slope and our distances. First up, hi, our change in y, is +3 divided by a +1, which is equal to a +3. I to j, change in y is +2 divided by change in x is -6. That is a -1/3. J to k, our change in y is -3 divided by our change in x is -1, and this becomes a +3. For k to h, our change in y is -2 divided by our change in x is +6. -2 divided by +6 is -1/3. These slopes that are simplified are there to help us determine parallel and perpendicular, but our change in y and change in x is utilized in both the slopes and the distances, because your change in y is either your a or your b, your change in x is the a or the b, depending on which order you want to put them in. Looking at these slopes, we want to compare anything. We want to first look at opposite sides, which are hi and jk. Hi has a slope of 3 and jk has a slope of 3. That means that these are parallel. So we do have a set of parallel lines. Opposite sides are parallel. We also want to look at ij, segment ij, and segment kh. They also both have a slope of -1/3. So those opposite sides are also parallel. I'm going to write a little note down here so that I have a little bit more room. We do actually have opposite sides. We have two sets. Opposite sides are parallel. So we know that we can get rid of a kite and we can get rid of any trapezoids as well, because trapezoids only have one set of parallel lines, a kite has none. So now we're between a parallelogram, and we can also get rid of just a quadrilateral because we do have opposite sides parallel. So we're between a parallelogram, a rectangle, a rhombus, and a square. Now we also want to look to see if we have any perpendicular, because that would help us go towards a rectangle or a square, because those have right angles. So we want to look at the connecting sides, like 3 and -1/3. Well, 3 and -1/3 are opposites. Positive and negative are opposites. And 1/3 is the reciprocal of 3. So these are opposite reciprocal slopes. That means that these connecting sides are perpendicular. So we'll put, but connecting sides perpendicular. I put the symbol for perpendicular as the upside down T. That actually tells us that we are between a rectangle and a square, because only rectangles and squares will have that right angle with the opposite sides being parallel. So we can eliminate multiple options here because we know the opposite sides are parallel and the connecting sides are perpendicular. We're down between to two options, rectangle or square, and that all depends on the distance now. Let's continue with our math. We will do all of the math. For h to I, our change in y is 3, so we'll have 3 squared plus change in x is 1 squared equals c squared. We'll solve for c, take the square root. 3 squared plus 1 squared is 10, so we'll have square root of 10 units. From I to j, your change in y is +2. plus the change in x is -6. So we will put that in parentheses. Or you could just use the value of it because it's just counting. Change in x of negative just means you went left 6. So it's still just 6 spaces that you counted. We will solve for c's. We'll have the square root. 2 squared and 6 squared. So we have 4 and 36, which is square root of 40 units. Automatically, these are not the same, so that will eliminate square. But we do want to make sure that a rectangle is still there by showing opposite sides are congruent as well. So we do have to keep going. From j to k, our change in y is -3, so we'll put -3 in parentheses, or you can just use the positive value of 3, plus change in x is -1, again, -1 in parentheses squared, or just use the positive one because it's just counting, equals c squared. We'll solve for c, so we'll take the square root. 3 squared plus 1 squared is 10, so we have the square root of 10 units. And our last one of KH, segment KH, change in y is -2, so parentheses -2 parentheses squared, plus change in x was the positive 6 squared equals c squared. We're solving for c's, we will take the square root. -2 squared is 4, 6 squared is 36, so 4 and 36 is 40, so we have the square root of 40 units. Now looking at our sides, we do not have all sides congruent, so that does eliminate the square. But we do have 2 sets, so square root of 10, square root of 10, and square root of 40, square root of 40. 2 sets of opposite sides, because we know that these are the opposite sides. 2 sets of opposite sides are congruent. That tells us it is a rectangle. That is our classification. Our last thing to do on this problem is to find the perimeter, which is adding up all the sides, which is the square root of 10 plus the square root of 40 plus the square root of 10 plus the square root of 40. Again, do not simplify these ahead of time, or do not put them as a decimal ahead of time. Put these into the calculator as they are, and then round your final answer. So we'll get approximately, I'll round this to the nearest hundredth, 18.97 units. Or it's technically 18 and 97 hundredths is how you would say this correctly. Our perimeter is 18 and 97 hundredths units.